Hey everybody, Norm here. You've got a situation on your hands. You're in the lab, you need a power supply. Somebody comes up to you and says, hey, I've got one, and it's even automatable. It's got the powers, the voltages, everything that you might need up from it, and it even has a little USB port so you can just plug it right into your computer. Should be able to work pretty easily, right? Except when you get to your computer, you find out that the only way to communicate to it is through their own custom interface, and basically you have zero idea of how to talk to it through any other programming language for your actual automation needs. So in this session, we're going to step into the lab into this very realistic situation. We're going to go ahead and do a little bit of digging to see how this is communicated to, how you pull information back to it. And we're going to leverage the power of LabVIEW to go ahead and actually all of the communication protocols, do a bunch of bit twiddling, and basically creating an interface as well so that you can have an open platform for you to be able to interact with this device over your computer, to get your data back from it and log it, and maybe even take it all the way to creating a measurement plugin so that you can even use Instrument Studio to go ahead and automate a simple device just like this. Let's go. All right, so first up, we're gonna go ahead and kind of preface this. This is gonna be a two-part, basically, walkthrough. We're gonna do one part, which is just how did we actually figure out what the communications were coming off of this? And then the other part, how can we start to actually create a driver through the automation in LabVIEW? Both of those are gonna elevate different features within the product, so stay tuned and stay sharp because there's gonna be lots of little nuggets that'll drop out there throughout the process. All right, so step one was I had to figure out, how to connect to this. When I bought it originally, it came with a little micro CD. Those don't even exist on laptops anymore, CD drives that is. And so I had to find out, I downloaded the driver. It was some YouTube video. I'll link to it below in the comments. But what I ended up doing is finding it and installing it, and we'll go ahead and open it up here. All right, so I found it. Once again, it's not really an installable program. It's just an executable. So it's there. There's some features you need to look at configuring it. That's less important, but I should be able to go ahead and click on direct device, and you can see that it's at 9. If I do the split right there, you'll see it's currently at 9. And if I were to go ahead and say change that to 5 volts, go to setting success, and you can see that we're starting to ramp down the voltage. It's got an internal bleed off resistance. You can see the graph update there. So no real surprise. It's good that we've got a good valid connection. And some of the things that I noticed, especially getting it configured, is that it communicates over a USB connection, but it emulates a COM port. Now, I was hoping that it was maybe a TCP port or some kind of other network port going into it, because then I could use a great little tool known as Wireshark. And if I were to go to here and type in Wireshark, you'll see it open. And the reason that Wireshark is such a powerful engineering tool, it's not an NI thing, but it's just good to know, once again, tips and tricks here, is that it allows you to basically sniff the traffic of basically any network connection. You can see what my laptop's doing here. Now, your laptop or your whatever is connecting over a connection is sending binary data back and forth that's packetized up into little chunks. And this concept of packetizing data matters a lot when you're looking into the communications of something. And if I were to go ahead and stop this here, I could click on it like any one of these rows, and here's the binary blob of information. Now, some of it you can kind of see, some of it is raw text. It's kind of ASCII characters overlaid on top of it. But some of it here you can kind of quickly see, it's just gobbledygook in terms of like, what are these characters? They don't map to anything. But one thing that is Wireshark does is it breaks apart that gobbledygook of binary blobs into the different relative information. So I can kind of expand it here, and you can kind of see all of the actual things that are loaded up into that binary blob. And this matters quite a bit, because one of the things that I found out very quickly, not only even after connecting it to a COM port and doing a little bit of magic to sniff on the COM port, is it's just transferring binary information. But you're in luck. LabVIEW does a lot of favors for you when you're interacting with binary information from there. So let's take this concept of what I like from a tool that, once again, isn't something that we make, but we can leverage it and we can recreate it in our environment and leverage the possibilities, kind of the features within the environment to go ahead and get further. So let's go ahead and close this down because I can't use it. I thought I could. It doesn't work for a COM to serial port connection. So what I ended up doing is, once again, it's here. I configured that executable that I was looking at to automate my device underneath COM10. So that's that linkage chip. Okay, as previously mentioned, I've got the executable and it's been configured to talk to COM port, right? There's the established port number has already been happened in terms of what the actual device, how to talk to the device. So I'll configure COM 10. And that's what we were looking at just a moment ago. That indeed is functional. But one thing about this link is that any COM port kind of gets reserved. You can't allow anybody else to look at the exact same number COM port. And so I can't just make another program over here, you know, .vi, and use Visa as basically the protocol that can talk to COM ports and TCP ports and so on. I just can't tell it, look at COM10. It's going to bark at me. It's going to say, you're not allowed to do it. The port has already been reserved. And if you don't trust me, please do. I've already gone through this a bunch of times, remembering it the hard way. So I can't just point it at COM10 and say, hey, look at what I want. And this is where a tool that's referred to as Com0Com, or a null modem emulator, comes into play. So it's a null modem emulator that has the ability, it's kind of an open source GPL license, so you can use it at will. But maybe not this page, but maybe the download page kind of describes it the best, where it makes basically 2 virtual COM ports on your computer so that one program can connect to a specific named COM port and another one can connect to a different named COM port, but it's as though they would have connected together. And so let's see what that looks like a little bit, so maybe you can follow along at home. So if I go and I look here, you'll see that I already have it set up here for port 19 and port 20. So now what I'll do is, instead of pointing the application to port 10, which is going to go directly to the device, I'll point it to 19. Let's go ahead and get out of here. Let's go ahead and redraw this a little bit. And so now I'm going to point this to point 19. LabVIEW is now going to basically set up a listener, kind of a bidirectional path for COM20, and it'll be as those 2 programs are actually linked together. And then COM10 will also now, instead of going to that application, LabVIEW will now be the one directly communicating with the device in case there needs to be any kind of bidirectionality. But technically speaking, we don't even need to do that to start, because one of the very first things that we would presume into existence is when the executable starts, it starts sending requests down to the device that it's pointed at. So let's go ahead and see what this looks like and how LabVIEW actually accelerates through a lot of the tools that are just kind of built into the product, how you can go ahead and kind of start sniffing in on some of this communication. Okay, with any serial connection or COM port connection, there's a few different things that can make your life a lot easier. And in terms of doing it with NI software and with LabVIEW, you have a couple different options. So one of the things to note is that you need to know kind of the baud rate. So you need to know right now in terms of like, hey, I've got 9600 as my very specific baud rate. And there's some other information too, like the flow control and other things that you might have to just mess around with or not. But once again, these are things that you can kind of figure out in a bunch of different ways. But one of the things that you would do with NI software is either would use Measurement and Automation Explorer, which is kind of the classic way of configuring NI hardware and other things. And indeed, once you connect to the devices and interfaces, you should see the various COM ports configured here. Well, what we want to do is we want to set up our virtual ports, that 19 and 20, to match exactly what 10 is. Now, by default, we said it was 9600, and then we can kind of scan down here in terms of what some of those other settings were. We believe that these are like the default COM setting ports, and so we can go ahead and just kind of map those to 19 and 20. But one of the things to note, if you've been an NI user for a long time or just getting started, we're kind of migrating to a new tool referred to as the Hardware Configuration Utility. Basically, it's a more modern version of Macs that we're going to continue to add new features into because it's basically built on a platform that's going to scale better with time. And so one of the things that you would do to configure those same things in here is find your system and then click on that basically as your port configuration. Boom, and now we can see over here to the left hand, sorry, to the right hand side, basically the serial configuration that we've got. So same thing as that what we had before, is we had, it was port 10, it was configured as 9600, 8, 1, and 0, or we can go down to 19 and 20 and we can configure them there. So if you haven't seen this before, new thing to recognize is out there and to start to experiment with and see and leverage, because I believe it allows you to connect to the current computer and different ones. Once again, a lot of new features are going to continue to end up in here over time. That indeed is that hardware configuration utility. All right, so the instrument is set up. Our COM ports are set up. Now we've got to set up our listener to go ahead and listen to the other side of that null modem. So we're going to get into LabVIEW and start to do that. Now, in order to connect to a serial port, or basically create a serial port listener, we're going to leverage the Visa API. You've heard me talk about that before. The way that you would get to that is basically go to the functions palette and start to go to the instrument IO section. Not too surprising. We're connecting to an instrument. That's where we're going to go. Now, we have two different ways that we can do. We're going to leverage Visa no matter what, but we can use Visa here, which doesn't allow an immediate connection to a serial port, or we can use kind of the serial palette that goes ahead and actually gives us a programmatic way of setting all those variables that we did interactively. And we're going to go ahead and do that so we can show off a couple different things here. So I'm going to drop it on a diagram. And one of the very first things that you might want to do is like, well, what are the inputs and outputs for this? Another great feature of LabVIEW is the context help. You know, some of you out there might already know this by the back of your hand if you've been using LabVIEW a long time. But for those of you who are just getting started, a lot of people don't realize all of the information that you're looking for is available there just by pressing Control H, or actually on the block diagram or front panel, this little question mark that you see right next to the icon up there. So let's go ahead and hover over that again, and I can see all the ins and outs. Now I can go through and say create a connection the definition of what I'm connecting to by starting the wiring, and if I hold down the Control key, double click, now you'll see that I have a constant on the block diagram to connect to it. If I needed to create a terminal, I would just double click and it would make a terminal. That's a new feature, I think, in LabVIEW 2023, Q3. In any case, if you're on the latest and greatest, that is a huge productivity accelerator courtesy of LabVIEW R&D that I love. I love it way more than I thought I would. But let's go ahead and make that constant again. Boom, right there, I'm gonna connect to port COM20. And that's another great thing about LabVIEW. A lot of people might not even think about it, but think about programming in other languages. Do you actually see as constants on the block diagram what's already connected to your system? And you're able to interact with that data in a very rich manner. Not really. LabVIEW is that great accelerator. So I'm gonna go ahead and select that COM20. I've got my serial port. Now there's a lot of other ins and outs that you can see in the context help window here. So what if I wanted to just mess with those programmatically? Another great feature that you've got in new versions of LabVIEW, press Control Space and Control Shift D, and that will create all constants for that function. Now, what are all these constants? They're laid out weird. Well, let's just press Control U, boom, cleans up the diagram. But I don't know what they are. I don't want to have to reference them. I want to see a label. Well, I can select all of them, right click and click on label. It will show the label to all of them now. Once again, I'll clean up that diagram. And now you can see we've got a diagram laid out really, really smoothly for all of the inputs. Now we'd have to reconfigure this. I don't think there's a termination character on mine. It is a 10-second timeout, so that'll give me enough time to kind of prototype here. 9600 baud rate, parity, none. I don't need the error in, out. There we go. So now we have basically the same configuration that we did interactively available on a program with a 10-second timeout. Now the other thing that I'm going to go ahead and do is I'm going to go ahead and create a Visa read. So I'll actually bring up QuickDrop, type Visa read, boom. Got it right there, hover over next to it. It'll actually automatically wire it up. I'm gonna say, once using that same tactic, I'm gonna look for, say, 8 bytes. Let's see if anything comes through here. And then I'm gonna create basically an indicator using that same tactic where I start wiring and double click. Boom, I've already got an indicator of the right type on the diagram so that now I can see the output in my read buffer on my front panel for when I connect into it. I'm gonna go ahead and do the error as well because I know it's gonna spit out a timeout error. All right, so let's go ahead and dive in and get this puppy going. So first and foremost, we know that we've got the COM port configured. We know that we can go ahead and double click over here and start our listener. We're gonna go ahead and do something. We're gonna actually set up our Visa read, and this is just good to know. If you're gonna do a Visa read, if you acquire or if you ask for more bytes than ever show up, it will eventually just kind of quickly time out and return back to you the valuable information. So we're gonna go ahead and take advantage of that here. I'm gonna go ahead and set that to say, oh, let's go to 32 bytes on our read. I'm gonna go ahead and create an indicator on that. I'm also gonna go ahead and create an indicator for the error so that it kind of shows up and stays resident. I'm gonna go ahead and actually make this a little bit bigger. We're actually gonna go ahead and increase the font size by doing Control Shift and then greater than. And then when we run this, we'll just go ahead and start it by running here. Oh, looks like it errored out already. Looks like there was data already at the buffer. So I'm going to go ahead and actually change something because it looks like it's gobbledygook at this point. Let's go ahead and look at the display style of the string. So one of the things that we noticed is not available or not going to happen is the device is not sending back ASCII characters, which would have made our lives way easier. We could have seen exactly what it was. But this is just one of those instances where LabVIEW's got your back. It's helping you out because interactively on the front panel with no extra programming, you can just very quickly change the display format of the actual data that came back. So I know that the characters are basically 8-bit representations of the relevant information. We can see that we've got basically a repeating pattern here. Let's go ahead and move this around. There we go. Now we can see the command that basically the running program sends over and over and over again when it tries to go. But I don't want this right now. Actually, I'm going to go ahead and that's from a previous iteration. What we're going to go ahead and do is just make sure we start from a fresh plate, and we're going to go ahead and press quick drop, but we're going to insert on the wire. So if you've never seen this ability before, you press Visa flush, I think it is, and then Control Shift I will insert a brand new function on pre-existing wires. Pretty nice. I'm going to go ahead and run it. Actually, let's go ahead and clear the front panel to reinitialize all the values to default. We're going to run the program again, kind of let it sit off here to the side, run it, nothing's coming through. Now we're going to try to run that DC program to try to connect in. There you go. So we were able to get exactly, once again, this program is going to fail because it didn't get a response from the device. We're not actually facilitating that through a modem just yet, but we can see we indeed got some information back from the device. And we can see this is basically, seems to be the command that gets sent over and over and over to the actual device for response. All right, so what do we do next? Well, what we're going to try to do is basically simulate basically or actually we're going to send this information directly to the actual device to see what it sends back. Or actually, we'll actually can kind of connect that in a tight loop, because then we've got that exact situation. We're able to have LabVIEW receive information from the program, send it to the device, know what that is, receive information back from the device, and send it to the program. So everybody thinks everything's happy hunky-dory, but what we're going to end up on the other side is a log of communication back and forth, and that's exactly what we're looking for. So let's go ahead and dive in to see what we would do within LabVIEW to do that. Okay, so through all that, one of the things you may have noticed is that I created a program, and I'm just going to walk you through it real quick here, that basically, if I looked at the program, it should basically describe itself. I'm going to read 8 bytes from the actual program that's sending it, send it to the device, and after a little bit of experimentation, I realized that this device responds with 7 bytes in return. Now that might not be everything, that might be every time, there's a little bit more information I need to dig, but what I'm doing here is basically sending that back to the original program itself. So basically very easy, happening in, not necessarily completely in parallel, but a pretty descriptive thing. And then I'm also building up the read buffer of everything that I've got here. Once again, now part of the value in LabVIEW is that the data is still live kind of interactively after the fact if it's on the front panel. And now we can actually continue to do our debugging. And that's really where the acceleration using LabVIEW as your tool matters quite a bit. All right, so we've got our program. We can see the commands. Basically, we have our listener set up. It's feeding information kind of back and forth, and we can see that it's sending the same information over and over again. And actually, the device seems to be responding as well. So kind of the same information, same commands, same data. So let's go ahead and stop the LabVIEW program and investigate a little bit. Once again, we're leveraging the environment and the language and the features to try to do a little bit of reverse engineering here. So let's go ahead and stretch out that data. And remember, we said that there was a bit of a repeating pattern in terms of basically querying probably its current status, so we would expect to find kind of a repeating pattern down here. Now we're also going to look for that kind of 0103 pattern, and there's a 0103 because that's probably the response that we're looking for. And then basically, actually, let's go ahead and there's one right there. Let's go ahead and trim off the data ahead of time, and we can start to figure out, hey, where is our repeating pattern in our overall program? And you can kind of see, because the data itself, there we go, we can see that we have this 0103 yada yada yada, and eventually it actually repeats, but not on an even integer boundary. So we need to go ahead and take 2, 4, 6, 8, 10, 12, 15. This is once again 2, 4, 6, 8, 10, 12, sorry, 13 specific bytes back out of this chunk so that we can start to decompose what's part of it. But now we have information going indeed in both directions again. We've got the command to query the information, which if that's all that we really needed to do from our automation program, that's great. Let's go ahead and just leverage that. However, the other thing that we need to do is to be able to properly get the information back in terms of what the device is sending us, and we've got it right here. All right, so I know you've been waiting for it. Let's see some LabVIEW code actually read data from this device. We're going to do just the reading to first because of the length of the video, but we're going to get to controlling in a future one or afterwards in the full cut of this. So what do we need to do? Let's go ahead and look. So we've got our controls and indicators. Basically, I'm just going to do VESA write, because I know the exact command. I'm going to do VESA read, because I know that I need 13 bytes back from it. I'm going to do VESA close, just to make sure that the system doesn't bark at me. I'm going to select them all, Control Space, Control Shift W, to go ahead and get them all wired together. Let's make a little bit of room here. I'm going to go ahead and take what I have here on the front panel. That is my what I need to write to the device. I know I'm going to COM10. And now if I run this over and over again, I'm going to basically be able to go ahead and I've got the read buffer. Let's go ahead and change the view of it a little bit to hex display and make the text larger. And run it one time. What are we missing? Oh, I need to get the byte count. All right, let's go ahead and make that 13 bytes that I'm getting back. Hey, there we go. So now I can run it over and over again. And if I were to go ahead and change the value, I think here on the screen from say 1024 to say 1023, let's run that over and over again. All right, now we know that it's changing. I know that it's my CRC on the end, and the 04, this byte and that byte right there constitute my voltage in the overall system. So let's yank those out and get those formatted so we can see it on an individual graph. So that's the 0, 1, 2, so index 3, index 4. So I'm going to do string to byte array, basically breaking a string up into its individual bytes. And I believe it was NDX index array, so I'm going to go ahead and get those elements out. And then I'm going to use a feature that exists within LabVIEW that is basically something that you might not be used to in here underneath the data manipulation palette. So if you've never spent any time doing bit twiddling, well, welcome to the fold. But underneath data manipulation, there is a function here called join numbers, and it allows me to take two numbers of any bitness, well, they have to be the same, I believe, and then create the higher bitness. So I've got two U8s, I'm going to combine them into one U16. So I'm going to do join array, or join numbers. I'm going to say starting index 3. 3 is the high, that's the low. I'm going to go ahead and create an indicator out of it. Let's go ahead and make that nice and big as well. And if I run this right, it should show 1023. That is fantastic. So let's go ahead and do that split screen again. And I'm going to go ahead and run continuously. And you can indeed see me go, as I change the value on the screen here, it should be updating with whatever we're looking at on the front panel. Now, indeed, I see 9.91. That's because it's integer. It's just a really simplified way. The last two digits are always the decimal point, so no big deal. So we have a fully functional system where I can get my voltage back over time, my current over time. I needed to use this actually once upon a time when I was doing, I was charging a battery, and I just wanted to see if at any point in time the voltage dropped too low and the current went too high. I was going to send myself an email. So that's what I wanted it for, and I couldn't monitor it in any program the way that I wanted to. So now that we've got this, I'm going to teach you one last thing that's particularly handy. So if I wanted to watch a trace of this number versus time as I moved it, you could create an indicator on the front panel, but that wouldn't be nearly as educational and helpful. So what I'm going to do here is actually, let's move it around on the screen a little bit. I'm going to do something where I use something very unique that a lot of people don't know about. It is this right here. It's the ability to create a custom probe without creating a custom probe, where I can say I want to probe a number, any number, and I want to go to the waveform chart. And now what I can do is I can look at the representation of a simple number logged over time without any extra code made. I don't even need to mess with my front panel. Let's go ahead and pop that out. And now you can see it. Let's go ahead and spin that wheel a couple times. Let's go ahead and do that split. There you go. And so indeed, now you can see as I go through, I'm really, like it is a great, it's not super fast, but it indeed is just it's just a power supply. It's not going to change that quick for me. It's not an SMU or anything. And so now you can see I have that type of control. And so hopefully those things gave you a little bit more insight of how quick it could be. I mean, let's just go look at that program again real quick. I mean, you can't get much more simpler than write, read, and then get your information out of it. You're already plotting, you're already doing the things that you need to, and that was a huge accelerator for me. Now that I finally have decoded all of the bytes and that are coming back off of the system, I've got a system that I have basically able to give me what I'm really looking for, and that meatiness of interactivity, the meatiness of being able to visualize the data, whether it's running or whether it's not, to look at it in different formats and take advantage of something beyond just once again, just strings being displayed, white strings on a black background as you get in a terminal. Being able to interact with your data so richly matters so much in moments like this. So, I know that there was a bit of a longer walkthrough looking at the diagrams and the code, and I know you didn't log into this to figure out exactly how to work this, but I wanted to walk you through a really realistic situation. Once again, setting up, a couple tools that aren't even NI tools that now you know about that are hopefully going to help you out in the future. And then also the ability to just, once again, use Visa, use the ability to go ahead and use the indicators and controls and even the things that I was using on the diagram, I didn't record nearly as much as I wanted to, showcasing little tips and tricks along the way. And maybe I'll even catalog them and make one after this. So, for those of you who want that, please leave your requests in the comments. I value those. If you found this not useful at all and you just want more LabVIEW, that's okay. I do too, but also I want to go through and show some realistic scenarios and highlight just the little ways that accelerate you through doing these engineering tasks that we run into every day, these challenges, these problems, these things that force us to use our creativity, but then ideally also allow us to leverage the language that I know I love, and hopefully you're seeing the power in as well in all of this. So with that, hopefully this gives you the ability to understand how to take a power supply that is sort of automatable and look at its communications. Use LabVIEW, use its built-in libraries for not only visualization, but also communicating with real-world devices, and figure out what it takes to get operational, to automate the way that you want to as fast as possible with LabVIEW and with NI. And I'll see you in the next video. Thanks.